Hello, in this lecture I will try to answer the question, is the universe infinite? What is the universe? The universe is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. So there is a big explosion of the universe that was in one small point and it expanded until the universe that we see today. Okay, according to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 19.3 billion light years in diameter at the present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang. So any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but it is impossible to say for sure that is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privileged or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions and on a large enough scale the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is indeed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. it could have a positive curvature, which is like the two-dimensional curvature of the surface of a sphere, like this. So this is in the state that the universe is with a positive curvature, and the surface is a sphere. That is to say, the universe is the universe closes inward, and it is finite. Yes. The second possibility is zero curvature, which is like a flat plane. So when the curvature is zero, or the universe has no curvature at all, then it is like a flat plane. Then the universe is not closed but infinite. And the third possibility is that the universe is with a negative curvature, which is like the curvature of the surface of a saddle. So then the universe is not closed at all, and it is infinite. So if the curvature is negative, the universe is infinite, like the saddle. The shape is like a shape of saddle. If the universe is isotropic and homogeneous, and the curvature of the universe has a constant positive value, like the sphere, then the universe will be finite, just as the surface of a sphere. Yes? And on the other hand, if the curvature of the universe is a constant of 0, then it is like a flat, yes, a plane flat, or constant negative curvature. That is to say, the universe opens outwards and never closes. The universe would be truly infinite. So if the curvature of the universe is negative, or the curvature is 0, then the universe is infinite. And if the curvature is positive, then the universe is finite. Do we have any measurement of the amount of curvature that the universe has? Yes, there is. The standard model of cosmology, which successfully fits all measured cosmological information as a parameter of total omega, which is related to the curvature. So total omega is actually a number that measures the curvature of the universe. If total omega greater than 1, then the universe is positively curved. So if total omega is greater than 1, then the universe is positively curved. And if total omega is exactly 1, then the universe is then uh, the universe is flat and infinite, and if value of total omega is less than 1, then the universe is negatively curved. So if total omega is less than 1, then the universe is negatively curved. Okay? The best measured value of total omega is 1 plus minus 0.12. Okay, total omega equals to 1 plus minus 0.12. If total omega equals to 1 plus 0.12, that is 1.12, that is greater than 1, then the curvature of the universe is positive. Yes, 1.12 is greater than 1, and in this case, the curvature of the universe is positive. And the universe is in a shape of a sphere, and the universe is closed. If total omega equals to 1 minus 1 minus 0.12, that equals to 0.88, that is less than 1. So if total omega is less than 1, then the curvature of the universe is negative. And then the curvature is negative. So if omega is less than 1, the curvature of the universe is negative, and the universe is in a shape of a saddle, and the universe is infinite. So all the possibilities can be true, which obviously could encompass everything from positive to 0 to negative curvature. Okay, so the universe could be with 0 curvature and thus it is infinite, or with a negative curvature like a saddle and is, in this case, it is also infinite, or if it is with a positive curvature, then it is closed and finite. So there is no definitive answer to this point, but the universe is consistent with having 0 curvature, because the total omega is closer to 1, because total omega equals to 1 plus minus 0.12, so it is very close to 1. That is the reason that the universe is flat, yes? So we really don't know if the universe is infinite at this point, but since the value is so close to flat, that is close to 1, because that's the reason that is close to flat, even if the universe is positively curved and finite, it would definitely be much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown since it cannot be observed. At the moment, we don't even know if it is finite or infinite, but there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.